All right, so you've probably noticed in a bunch of your classes that you're doing kind of a little bit more of this literacy stuff, okay? Because that's kind of been the big push in our school division here over the last year and a half or so, okay? So in science, what we do rather than teach you how to read, okay? Because we're really, as science teachers, not really experts in that. What we do is we kind of work on your scientific literacy, right? And what we mean by that is being able to read something like a scientific article or something like that.
Sorry for the interruption. Today is Picture Retake Day, and we're going to try to have as few interruptions as possible.
Okay, so what we work on here, guys, is your scientific literacy, which means you read a scientific article and you can evaluate it. Okay, you can read it and go, well, is that person's argument really an emotional argument, or is it a scientific argument? Is it valid or not? Okay, and we work on a lot of the scientific terminology. All right. From what we've read, okay, in terms of this literacy project, is that we want to have people reading at about 97% efficiency, okay? That means you know 97 out of every 100 words on average that you read, okay? Now, that may seem kind of odd that we wouldn't want you to know all of them, but realistically, you never really know all of them, all right? Even when I'm reading stuff, I get through it and I hit a word sometimes like, I wonder what that is. But you can usually kind of figure it out. Okay, you can figure it out from either the context of the paragraph, or if you've seen another word that's like it and has a similar meaning. Okay, things like that. And so that's kind of the skills we work on when we're doing scientific literacy type of things. All right. So the idea here is you're going to be reading this little article on how reverse osmosis works, because it's a practical application of cellular transport principles that we've been talking about, osmosis and active transport, diffusion, and all that kind of stuff. All right. So what I want you to do first is I want you to read through the article. Now I've underlined and highlighted a few things, a few of the words that may or may not, okay, prove difficult for you. Okay, you guys probably will know what most of them are, but okay, they're things that I think might put up flags for some people. If there's other words that I have not highlighted, in fact, what I would like you to do is underline any words that you don't know as you go along, and then when you're done, okay, what we're going to do is kind of review the article together, go over any words that anyone missed, because obviously if you didn't understand a word, that can interfere with your ability to understand the sentence it's in, the paragraph it's in, and then you're missing kind of big chunks. All right, even reading at 97% efficiency, guys, if you read, okay, like a big thick book, you could be missing several pages of that book. Okay, my colleague Mr. Dickey was illustrating that the other day. His son had just read some fantasy book, and it was thick. Okay, and he said if he's reading at 97% efficiency and he had it bookmarked, he had it paper clipped actually, how much of the book he didn't understand. And it was a thick chunk of the book, even at 97% efficiency. It's 3 out of every 100 pages, right? Okay, well, if you're reading a 1,600-page book, right, that starts to add up. You guys with me there? It's 48 pages, right, that you didn't get? Well, that's quite a bit, right, when you kind of see it that way. So what we want to do is make sure that you understand everything that's in here. Kind of read it through once, and then we'll go through anything you don't understand, kind of review the key concepts here. And then at the end, okay, the thing that you guys have to do for marks here is answer these 4 questions based on the article, right? And you'll have whatever time we have here in class today to work on that. All right, everybody with me where we're going so far? All right, so get started on reading that. Shouldn't take too long. I'll give you some time, okay? And then we'll make what we usually call, in literacy terms, a word wall. I don't know if you've ever done that before, but we'll write the words that we don't get up on the board. Don't be shy about saying which words you didn't get, okay? It's important that you say that, okay, so that everyone understands. Chances are, if you felt shy, there's probably 5 or 6 other people who felt shy about saying they didn't know that word. Just say it. No one's going to laugh, unless it's the. Okay. All right. Let's go over a few of the ones that I think might have been troublesome or kind of maybe new vocabulary for you, and then we'll make a list of any ones that aren't on my list, okay, that you guys had trouble with. We'll make sure everyone understands those. We'll also look at them in terms of the context they were in, okay. So first one there that I had highlighted was desalinization. Now they do have kind of an explanation as to what desalinization means afterwards. Okay, desalinization, if something is saline, what is it? Yeah, it's a solution. It's a salty solution, right? If you use saline solution on your contact lenses, right, there are certain types of salts in that, okay, that are used to clean and remove, scale buildup and stuff like that in your contacts. Anything that has to do with salinity, okay, has to do with the saltiness of a solution, all right? So desalinization would mean to remove the salt, okay? All right, so again, it's those kind of tricks that we use if we're trying to figure out a word, right? We find pieces of the word that we know or we recognize, okay, and then we can figure out the rest. All right, what about unprecedented? If you set a precedent, it's kind of like setting a what? Okay? Setting a precedent is kind of like setting a record. Okay? If there's a precedent for something, it's kind of the standard by which everything else is measured. All right? If something is unprecedented, there's never been anything like that before. Okay, you guys follow me there? All right, like this year, all right, the amount of rain we had and the amount of flooding we had was unprecedented. Okay, we've never had anything really like that in recent memory. Okay, that was at least as damaging as it was this year. Right, so it was unprecedented. Right, and then torrential. Obviously, we all know what flooding means. Okay? Especially after this year, we all know what a flood is. Okay, torrential means. Yeah, torrents, like a torrent is a fast-running stream or river. Okay, torrential means exactly that. It's really fast-moving flood water. Okay, basically unstoppable. It does a lot of eroding and movement of material. Okay. Other ones here. Okay, semi-permeable membrane, an important one because our cell membranes are semi-permeable. That means that some things can get through and some things can't. Most of the time, semi-permeability is based on size. Big things don't get through, small things can. All right? But it could also be not just semi-permeable, but selectively permeable. All right? Our cell membranes would also be considered selectively permeable, as they can sort of choose what gets in or out. All right? If something is permeable, everything can get through it, because it's from the word permeate. If something permeates, it's kind of in everything, right? So if something is permeable, everything can move through it. If it is semi-permeable, only some things get through. Everybody with me there? All right. So in this one here, where they're talking about, okay, osmosis being the passage or diffusion of water through or other solvents through a semi-permeable membrane, okay, they're talking about how water can move, but other things get blocked. Okay, and that's the principle behind osmosis and the principle behind reverse osmosis. Okay. Osmotic pressure, probably another one. Okay, osmotic pressure is simply a pressure that's created by the fact that everything's always got particles that are moving. Okay, and that movement, especially if there needs to be a movement of things from one side of a membrane to another, creates pressure against the membrane or pressure against the other particles, pushing or pulling them in a certain direction. Okay. All right. Concentrate. Ever heard the look on like a can of juice and it says from concentrate? Okay. What does it mean if you've concentrated something? Or more, makes the solution closer to saturated? Yeah. Okay. If something is from concentrate, essentially what they've done is they've wanted to save weight and packaging. So they've removed water. All right. So when you have that, can of frozen orange juice, all right, it was made from real orange juice. It's just they removed a lot of water from it, either through a membrane or through a distillation type of process or something like that, that removed some of the water and made it much more concentrated, much thicker. All right. But then, of course, it takes up less space. Okay, it's less heavy. It doesn't have as much mass, so it doesn't require as much trucks to transport it. Things like that. It's just kind of an efficient way. It's less packaging, all of that kind of good stuff. All right. So a lower concentrate simply means that on one side there's less of something in the solution than there is on the other side. Okay. If something is really concentrated, okay, there's lots of it in there. All right, like my kind of Kool-Aid. Right, really concentrated, almost syrupy, okay, kind of saturated, and then there's, the kind of Kool-Aid most normal people probably make, where the bottom isn't a solid. Yeah. All right, bars of pressure, okay. Bars has to do, it's just a unit for pressure, okay, like millibars and things like that. just has to do with how much pressure is being exerted by either a gas or a fluid on something else. Okay, sometimes we also use millimeters of mercury. Okay, in the metric system, we typically use pascals as a unit for pressure, but they all refer to how much squeezing there is, okay, going on. So this is talking about how much pressure would be needed to force the water against the membrane in reverse osmosis, okay, and leave the salt behind on one side and force the clean water through on the other. All right, it's a fair amount of pressure. You can't just kind of leave it there and say, all right, go for it, because it won't work. All right, if you just put salt water on one side and water on the other, all that's going to happen is water will move across the membrane according to osmosis. But if you put pressure against it, it can't do that, and it forces it through the wrong way, hence the name reverse osmosis. Okay. Okay, those of you in French know what this word is. Voila. Okay, it means there it is, or there you have it. Okay, so in case you didn't know that, right? If you're, someone who doesn't know French, that's fine. Okay, but we sometimes in English use that term. Okay, so voila means there you have it, there it is. Okay. Skeletal fluorosis, again, another one where they had kind of an explanation for it. Osteoporosis would be a form of skeletal fluorosis where essentially your bones just get weak. Okay, they become more porous, and so they don't bear your weight as well, and you start to see a bending, okay, of the bones. If someone has rickets, okay, if you've ever seen anyone with rickets, they get like bow legs, okay, and it's not because their joints aren't aligned properly, it's because the bones are actually bowing. Like if you leave a piece of wood, okay, like a 2x4 against a wall, over time it starts to bend. Okay, well, it's the same thing with bones. If they're not strong, or they start to lose some of their calcium, they'll actually start to bend under your weight. All right, and they'll start to grow that way. All right, because what's stronger, an arch or a straight line? An arch is always stronger, right? Because it bears some of the weight differently, right? Well, your bones kind of, as they get exerted pressure and they're getting weaker, they try and kind of account for that by changing their shape a little bit. It isn't healthy, all right? The problem is that that's fine if you're straight up and down, but as soon as you start to move or put pressure because of your movement, you can snap your bones quite easily, okay? And that's what happens, obviously, to elderly people when they break their hip, okay, and things like that. Their bones have just become porous and brittle, and they can break much more easily, okay? I mean, you've all seen, elderly people, and they kind of get where they're hunched. All right, and that's because their spine is doing exactly the same thing. It's starting to bend, right, because the bones are getting weaker. All right. And impediment. If you impede somebody, what have you done? Yeah, stopped its progress, slowed it down, made it difficult. Okay, you maybe heard the term speech impediment. Okay, a speech impediment is a blockage. The way someone says something makes it hard to understand them. There's a blockage there, something that's slowing down the understanding or the communication. Okay, so anytime you have something that involves the word impede, it means to slow down or to make difficult. Okay. Now, WHO and UNICEF, okay, two world organizations that you may or may not have heard of. WHO stands for the World Health Organization. UNICEF, the little orange boxes full of pennies. Okay, it's the United Nations International Children's Emergency Fund. Okay, so it's essentially they collect all the pennies, and then when there's children in a state of emergency somewhere, okay, the money can be used to help them out, buy clean water, clothes, food, okay, things like that. Okay. All right. So when we're looking at all this stuff, okay, sort of in general here. Sorry, are there any other words that we should go over? Any other ones I didn't cover? Mac. Paramount? Yeah, okay. Paramount means like highest point or the highest standard of something. Okay, so if something is paramount, it's like, oh wow, that's the best it could be. Okay. Equilibrium. Okay, equilibrium means to balance. All right. So at some point, all systems try and achieve a state of equilibrium where movement both ways is equalized, okay, or they tip to a point where they stop moving. Equilibrium basically means you get to a point where things stop, they're balanced, and there's no pressure either way. All right, so when we're talking about a membrane with osmosis, you've got water moving to the more concentrated side, and it will continue to do that until the sides are both equal in concentration, and then there's a state of equilibrium. The water doesn't continue to rise and fall. It just stays. Yeah. Did I totally miss that? Where's that at? Where is reverse osmosis used? Oh, cellular acetate. Oh, okay. So the membranes, okay, so there's different types of membranes. These cellular acetate ones are essentially made up of an ionic acetate, the ion acetate, right? Okay, and it's polymerized, which means it's chemically joined with or fused with, okay, some cellular material. Okay, so it's essentially the same stuff. If you've ever held photographic film, it's stiff, but you can move it. It's kind of like you can't really twist it very well, but it's flexible in one direction. Okay, that's cellular acetate. That's what that material is. Yeah. Okay. Anything else there, guys? Caitlin? Arid. Oh, arid. Okay. Arid means dry. All right. So if you're in the desert, you're in an arid area. Okay. Yeah, arid means dry. They used to have a deodorant called Arid. Yeah, it would keep you dry, right? Okay. They don't have it anymore, obviously. Okay. But yeah, arid means dry. Okay. Any other ones? Oh, mottled. Okay. Yeah, mottled means you got like patches of different colors on your teeth. Yeah. Fluoridation means to add fluoride to something. All right, we add fluoride to our drinking water because it improves the quality of your teeth. There's a lot of people that are against that because they think the extra fluoride isn't good for you. What they don't realize, most of those people, is that you guys will probably go through most of your life without a cavity or with very few of them. All right, how many of you have more than one cavity? Okay. Okay, well, but now you know, right? You have your adult teeth, now you don't have that problem, right? Because it's hard to clean in between them? Yeah. Okay, but in general, people have better teeth now than they used to have. Okay, I mean, if I'd asked that question of, let's say, your grandparents, okay, maybe even your parents' generation, almost everyone's hand would have gone up. Okay, almost everyone would have had more than 2 cavities before the fluoridation of drinking water. Okay, fluoride helps to make your teeth stronger. It helps to build enamel, okay, which prevents cavities. Now, again, a lot of it does have to do with the structure of your teeth. If you have teeth that are really close together, it's hard to clean in between. Bacteria can get in there, and of course that's what eats away at your enamel and causes a cavity. Right? And it's not because you don't brush your teeth. I'm not saying admit you have cavities because you have bad oral hygiene. I'm not saying that at all. Okay? It just, most of the time, having the fluoride in the drinking water does make your teeth a lot better. And okay, if you look at the records of dental, health over the last 50 years, it's obviously a major improvement. And I mean, partially that's we got better toothbrushes, better toothpaste, but also fluoride in the drinking water. Yeah. It can get out easily. Yeah. Yeah. Some people are just lucky that way. It's like people who can eat whatever they want and never gain a pound, right? Okay. All right. Any other ones? Wastewater. So when we're talking about wastewater from reverse osmosis, it's the water left on the salty side of the membrane. Okay. So as we push water into the membrane, some of it gets through. That's the drinking water. The wastewater is the stuff that's now more salty than it was before. Okay. Any others there, guys? All right. So when we're looking at the questions here, okay, the 4 questions you got to answer here. Okay, talk about compare and contrast the membranes used in reverse osmosis. Okay, and in reverse osmosis, what was the membrane made out of? Well, there's 2 materials. There was the cellular acetate that we talked about, and one other material. We use it to keep us warm most of the time. Synthetic. Gore-Tex. Okay, Gore-Tex. Okay. All right, so we got to talk about how they're similar, how they're different. You may need to refer back to your notes to recall what the cell membrane is made out of. Remember, the analogy I used was if you made fruit salad and then poured Jello over it and let it solidify. Okay, you'd have kind of like what a cell membrane would look like there. This material with chunks in it. Okay, you got to figure out what those materials all were. Okay. What provides the force needed to move water across the membrane in both osmosis and reverse osmosis? And those are mentioned, okay, in that article. Okay, in osmosis they talked about the pressure that's used. In reverse osmosis, it's artificial, but you have to explain how they might cause that pressure to be there. Okay, explain why one process requires energy and the other is passive. In a short paragraph, explain and justify if you think using reverse osmosis would be an acceptable way to conserve water in a place like Okotoks where water conservation is important. Okay, so talk about, yeah, there's clean water is obviously important, okay, but are there ways we could get water that's safe to drink without using reverse osmosis? Which one would be a more efficient use or produce less wastewater? Okay. And then number 4, it was mentioned in the article that reverse osmosis was used to ensure impurities were removed from certain products like wine and syrup. Can you think of any reason why purists, okay, and purists are people who would say that cleaning something artificially might not be the way to do it. Like when wine is usually made, it's just you put it in a barrel and you let it ferment and then you drink it. Okay, it's a purist might say they wouldn't want it filtered. Okay, why wouldn't they want it filtered? Same with syrup. Okay, a purist wants it the way it would be naturally made. Might disagree with the use of that process in making these products and explain. Okay, so we're looking here not for like 1 or 2 sentence answers. Make sure you're incorporating the stuff from the article as well as the stuff you've learned in class so far about osmosis and cellular transport into your answers. Does everyone follow what we're looking for here? Okay, now you've got 35 minutes or so. I don't know if that's going to be enough for you to get all 4 done, but you'll probably get close. Okay, now when you do hand these in, I would like them typed. It's a lot of writing, and not everybody's handwriting is as good as mine. Yeah, right. Okay, please type them so that I don't have to read people's handwriting that's as good as mine. Okay, so awful. Yeah. All right, so let's get started on that. If there's questions, let me know. Okay, but again, this is kind of checking our understanding, checking our reading comprehension, and scientific literacy type of idea here. I just got to look at the calendar and figure out when it will be due.